Hello, my name is Kelly LeBlanc, VP of Marketing for 6WIND. Today I'm going to introduce 6WIND and how our vRouter technology can replace hardware routers. At the end, my colleague Jan Rappaport, 6WIND VP of Product Management, will join me to answer questions about our software. 6WIND is a software company headquartered in France with offices around the world, including Santa Clara, California, and Beijing, China. We make high-performance networking software with deep expertise in telecom. Our flagship product is VRouter software that has been deployed globally for over a decade. And for those of you from the developers community, you may know us as the founders of dpdk.org and a top contributor. In recognition of our innovation, we received an investment from Cisco and multiple awards, including NFV and VNF Products of the Year for our vRouter. Just last week, we won a Network Virtualization Europe Award for a successful SDN deployment of our vRouter within our service provider customer EOLO's network. In this case, EOLO replaced hardware routers with SDN routers. Before we speak about vRouter networking trends, it can be helpful to look at technology transformations over time. We can see many historic cases in computing where hardware commoditization and software are key drivers of technical evolution to produce technology we know today. Cell phones and computers are two examples that many of us have experienced in real time. As we know well, cell phones and computers have changed dramatically since the 80s and 90s. If computing as an industry has changed so much, why is it that networking has not? We've seen the same routing technology since the mid-1980s, yet cell phones and computers have changed dramatically. Isn't networking due for a similar change through hardware commoditization and software? The answer is yes. The computing industry is always changing, and networking is an extension of that change. 6WIND is driving this change with high-performance networking software for commoditized servers. Our vRouters are an industry-leading example. We are witnessing the transformation of networks from the core to the edge, and high-performance vRouters are helping to drive this transformation. 6WIND vRouters solve networking performance challenges so that software can replace hardware. Our high-performance networking software is deployed on commercial off-the-shelf or COTS servers and removes common bottlenecks at different networking layers. One common bottleneck is at the hypervisor layer. This is for customers that are virtualizing their network with virtual networking architecture designs such as NFV. Another common bottleneck is at the application layer. Here the application can be deployed bare metal on the server or within a virtual machine. 6WIND provides an easy upgrade path from bare metal to virtualization using the same software for either configuration. 6WIND's vRouters are available in 3 different software packages for white box networking. The first is our 6WIND Gate software, which is source code for Linux networking. 6WIND Gate includes complete and modular layers 2 through 4 networking stacks. Here we help our OEM customers build their own vRouter technology and more, including a full range of additional networking equipment and solutions. The second are software appliances called TurboRouter and Turbo IPsec. These vRouters are ready to run appliances for customers who build and operate networks. This will be the focus on today's webinar. The third is virtual infrastructure software for hypervisor networking. These vRouters boost virtual networking and switching performance inside NFV platforms such as Nuage Networks AVRS and Contron SimCloud. Our software runs on market-leading processors that leverage DPDK for performance, including x86 and ARM. We've been solving networking performance challenges for our network builder and OEM customers who are using our vRouter technology for over a decade now. Our customer list is impressive, with a large global reach, including servicing over 90% of 4G networks in Japan, the top service providers in the US and EMEA, and more. These customers use our software with standard tools such as Linux on commodity hardware to solve some of the largest networking challenges in the industry. Now for more detailed information on how vRouters are replacing hardware routers. Today we will start with a history of software versus hardware routers. Then we will focus on 6WIND vRouter features and performance, deployment options, and markets and use cases. We will conclude with a cost analysis of software versus hardware routers. Let's begin with software versus hardware routers. Standard hardware routers as we know them today have been available since Cisco's introduction in the 1980s. They deliver very high performance, but at a significant expense. For over a decade now, virtual routers or software routers, such as Viada's vRouter, ViOS, and other Linux routers, presented an alternative to hardware routers through software that can be installed on COT servers. However, there was a huge performance gap between software and hardware solutions. We see this firsthand with customers who call us because their software router performance maxes out at 1 gigabit per second. And while hardware routers are expensive, software appliances have not been cost-effective as these performance gaps cause an inefficient and sometimes wasteful use of servers. Today, thanks to advances in high-performance networking, software appliances have the performance to replace hardware routers on standard COT servers. For example, at 6WIND, our vRouters deliver a range from 1 gigabit per second to over 200 gigabits per second on a single server, leveraging commodity hardware. We deliver this innovation by designing our software appliances on top of the Data Plane Development Kit, or DPDK, from the ground up. This technique allows us to bypass bottlenecks in the Linux networking kernel to deliver performance that was previously only available with proprietary hardware. Now let's have a look at our features and performance. 6WIND customers tell us time and again that our vRouters have the best packet processing engine they've ever seen. This is thanks to 6WIND Gate, our software foundation upon which all of our products are built. 6WIND Gate is the world's first packet processing software designed to take advantage of modern multi-core processor platforms and provide an acceleration solution for Linux. It has been deployed live now for over 12 years in the largest networks in the world, such as AT&T and OVH. 6WIND Gate delivers the fastest performance on the market for bare metal and virtual deployments through our dedicated and optimized data plane, also called the fast path, by offloading packet processing from Linux. 6WIND Gate incorporates our design philosophy of transparency so that performance benefits always preserve existing architectures. We do not change the Linux OS, hypervisor, or management. We also have a philosophy to be open and unlocked with support for all market-leading platforms to future-proof your investment. We combine over 350 working years of development time to deliver more than 50 popular network protocols with a specific focus on routing and security. Built on 6WIND Gate technology, 6WIND's vRouter is a full-featured software appliance delivered in software packages called Turbo Router and Turbo IPsec. Here you see an example of our Turbo IPsec appliance features, and our Turbo Router features are an exact subset of these. Turbo IPsec can be deployed in bare metal and virtual machine configurations. It serves as an alternative to expensive hardware-based routers as it delivers the same traditional routing and security features with similar performance and both traditional and IT-style management. We have no interest in vendor lock-in. 6WIND's vRouter is open to any COT server hardware that you select. 6WIND vRouter features include IPv4, IPv6 networking with support for VRFs, BGP, OSPF dynamic routing, tunneling, NAT, PPPoE, and L2TP client server, ACLs, GRE, VLAN, VXLAN encapsulations, lag, high availability, and more. Our customers deploy 6WIND's vRouter as an edge router within public and private clouds, inside UCPE and BNG solutions, and more. IPsec VPN functionality is available through IPsec and IKE features, customers that need secure tunnels and connections between sites, data centers, or mobile infrastructure are popular use case examples. 6WIND vRouter performance scales linearly with the number of cores deployed. Our TurboRouter software performance, running on an Intel Xeon Platinum processor, is impressive at 12 million packets per second per core. If you need more capacity, just add more processing cores to your configuration and enjoy similar performance whether running bare metal or in VMs. In this particular 40-core platform, over 200 gigabits per second can be delivered on a standard COT server with 45% of the server capacity still available. 6WIND's IPsec VPN performance is impressive, and this is one of the reasons we've won so many NFV use case awards. On an Intel Xeon E5 processor, we deliver 12 gigabits per second of throughput per core, up to 100,000 IPsec tunnels and 1,000 tunnels per second, all in software. And performance scales linearly with the number of cores. Combining VRF, IP and filtering to create IPsec VPN tunnels, we deliver 7 gigabits per second per core. And for customers who are now leveraging Intel's new Xeon Scalable processor family, you can see we increase performance by 50% on the new Intel Xeon Platinum processors. Here we can deliver 18 gigabits per second per core and 10.5 gigabits per second for secure VPN tunnels. It is the same 6WIND software that gives you a 50% performance increase on the latest generation processors. 6WIND vRouter performance scales with its available hardware. 6WIND software is hardware independent, allowing it to scale with hardware advancements, such as increases in frequency, processor cores, and NIC throughput. We deliver support for 1, 10, 25, 40, and 100 gig NICs. Our vRouters adapt to available processing resources from low-range to high-end configurations, allowing customers to deploy the right server hardware performance they require to create specific applications and services. 6WIND vRouters are available in 1 gig to 100 gig perpetual and subscription-based software licenses. Now let's have a look at our vRouter deployment models. 6WIND's vRouter has 4 deployment models. Here we see 6WIND's vRouter deployed bare metal on COT servers or within virtual machines. Within VMs, there are 3 options with varying levels of performance. The first is on top of standard open source hypervisor infrastructure using Open vSwitch or Linux Bridge, with hypervisor options including Linux KVM and VMware ESXi. The second leverages hypervisor bypass technologies such as SRIOV or PCI pass-through, which dedicate hardware resources to virtual machines for the highest performance, but loses some of the benefits of virtualization such as live migration. The third runs on top of 6WIND's Virtual Accelerator vRouter in the Linux KVM hypervisor domain for the best NFV-ready performance with 0 hardware dependence. Performance is close to bare metal, and virtualization features are preserved. We give you these different deployment options so you can make incremental software upgrades for your cloud transition. Remember, it's the same 6WIND software for bare metal or virtual deployments. Now, let's have a look at markets and use cases. 6WIND vRouters serve 3 discrete markets for telcos, enterprises, and cloud providers. We are seeing adoption across all of these markets, and I will now share an example for each. Let's start with a service provider example. AT&T has been a 6WIND vRouter technology customer for 5 years. AT&T uses 6WIND's IPsec VPN software to create its virtual VPN internet gateway that creates secure VPN services for its customers. AT&T was an innovator to run this service in virtual machines versus deploying standard hardware. As a result, they reduced their CapEx by 70% and are now using the same technology within their new SD-WAN services as well. This second example is for an enterprise who contacted 6WIND for a VIOS vRouter replacement. Arbor Networks is a large US DDoS protection company that runs a mission-critical private enterprise training network using vRouters instead of hardware routers. Its key requirements were performance and support. Arbor ran dozens of ViOS vRouters in its network, and these ViOS vRouters couldn't handle over 1 gigabit per second of traffic. So Arbor selected 6WIND vRouters as their replacement and configured and sustained 5 gigabits per second each for routing and tunneling. As a result, Arbor was able to significantly reduce its hardware costs through software. The third example is for a cloud service provider. OVH is a large global cloud provider with dozens of data centers. OVH took a strategic, visionary initiative 5 years ago to build software routers with 6WIND vRouter technology versus buying Cisco ASR 9000 routers. OVH wrote a nice blog that explained the details of its approach. It stated that 2 legacy hardware routers, each handling 120 gigabits per second throughput, were replaced by 4 vRouters, each handling 160 gigabits per second of throughput, saving 90% of the cost. A global data center rollout has followed since. Now we will begin our cost analysis of 6WIND vRouters versus hardware routers. This comparison is for a customer that requires 40 gigabits per second of IPsec performance in its router. We will compare 6WIND's Turbo IPsec vRouter with a perpetual license for 40 gigabits per second throughput and 40,000 IPsec tunnels versus Cisco's ASR 1006X hardware router. For the 6WIND solution, we combine the price of our Turbo IPsec license with the cost of the server hardware, which in this case is an HP ProLiant DL380 2-socket server with 12-core Intel Xeon CPUs. Then we apply a 20% discount to the combined solution. For Cisco's hardware router, we take 60% off list price. Here you can see that 6WIND is already saving over 50% of the cost. Now we add support. 6WIND support is 15% of the list price of the solution, and the first year of support is included in the list price. Cisco support is 10% of the list price. Now adding the solution price and support, we can calculate the first year total cost of ownership and cost per gigabit per second of IPsec. 6WIND's cost per gigabit per second of IPsec for the first year is $646, which is less than half of Cisco's price. Now we can calculate the total cost of ownership over 5 years, and 6WIND's cost per gigabit per second of IPsec is $930, which is roughly 1/3 of Cisco's price. And with 6WIND, 1/3 of the server is still available. This is because we have only used 16 out of the 24 cores to run Turbo IPsec with 40 gigabits per second and 40,000 IPsec tunnels. This leaves 8 cores available, which is 1/3 of the server, still available to add more performance or more applications to the existing solution. The additional value of vRouters over hardware routers is again multiplied with software. As I mentioned earlier, with 6WIND, 1/3 of the server is still available. This is where virtualization can really compound savings. If you combine the flexibility of virtualization with spare processor capacity that scales with the number of cores, you can do more on the same server with the same software. The Cisco hardware lacks virtualization and maintains fixed capacity, so additional hardware will need to be purchased for additional performance or applications. You can also see the big difference in space and power requirements with 3x overall savings from 6WIND. In summary, 6WIND's vRouter is available to meet serious networking requirements in software. We have the performance with 12 million packets per second per core, the full set of routing and IPsec features, and virtualization readiness to deploy in bare metal or virtual machine configurations today, with a seamless migration path with the same software. 6WIND's vRouter provides both traditional CLI-based management and IT-style management based on automation integration with high-level orchestration tools. For this, 6WIND vRouter proposes Yang-based netconf and REST APIs. We also have standard Linux APIs such as IProute and iptables. Configuration can happen through Linux, the CLI, and APIs for integration with third-party management tools and orchestrators. For monitoring, we support the traditional SNMP and syslog mechanisms plus telemetry through SFlow and graphical analytics with time series database, including pre-integration with InfluxDB and Grafana. Our data models leverage Yang and are therefore easily understandable and extensible. This concludes my presentation on vRouters replacing hardware routers. I will now turn it back to Eva for the Q&A session, where 6WIND VP of Product Management, Jana Rapport, will now join to answer your product questions with me in real time.
Yes, thank you, Kelly, for your presentation. So we will now start with the questions we received. So the first questions we received is, do we have comparable performance whatever CPU architecture is chosen, Intel or ARM?
Yes, so hello, Jan speaking. Nice presentation, Kelly. Hi, everyone. So good question. Thanks for the question. So yes, we can say for the benchmarks we've performed that the performance is comparable on a server basis, because usually the performance per core on Intel servers is higher than on ARM servers, but for the benchmarks we've done, the ARM servers have more cores than the Intel servers. So all in all, the per server performance is comparable. Then it's really a matter of use case. So 6WIND doesn't make the choice of hardware. The way we do things is we are agnostic of the hardware. So being the CPU architecture, or being the NICs, we support also multiple NICs on the market. So Intel, Mellanox, Broadcom NICs. What we want to provide is a software solution that is as open as possible to any hardware vendor, and then it's our customer's choice based on his use case, on his financial ins and outs to make the decision.
Very good. So the another questions from the audience is, do you deploy the vRouter in bare metal or in a virtual machine?
Both are possible, actually. So okay. It's a pure software solution. We have the right drivers to handle physical machines, so the physical NIC drivers, and the drivers to run in a virtual machine, such as Virta.io or VMXNet3 drivers. So both cases are possible, thanks to the pure software-based solution. Okay.
The next question. What are the supported NICs and the references?
Yes, so you can check all the details on our website, or just contact us offline for all the details. So we support Intel NICs, so Niantic, Fortville NICs, also known as IXGBE. I forgot the name of the driver for the Fortville, but so anyway, so all recent Intel NICs. We support also Mellanox ConnectX 3, 4, and 5 NICs, and the Broadcom Extreme Net series. But all the details are available on the website.
Okay. Next question. What about the deployment of vRouter with containers?
So that's a good question, and it's something we are studying at the moment. It's a request we start to see from our customers. Today, running DPDK applications in a container is not straightforward, so it's something we are looking into. Let's say it's work in progress.
Okay. All right.
Just one more thing on this topic. We don't see today use cases with high performance routing in containers. The use cases we see with high performance routing are in VMs or bare metal.
Another questions. Is the limit of 200 gig linked to the vRouter?
No, the limit in the benchmark we did was due to the platform. If I remember well, it's we had I think we had 20 10 gig NICs in the platform. So anyway, so the performance of the vRouter is per core and scales with the number of cores. So in theory, if your hardware allows it, the performance can be infinite. Practically, you will have hardware limitations. Depending on the number of NICs you can install per socket. And so yes, so in recent benchmarks we've been able to go up to 400 gigs on the platform with 40 gig NICs. But yes, so that's basically hardware limitations.
Okay, and do we support smart NICs?
So smart NICs are in progress, work in progress. We are working with smart NIC vendors to port our software on their hardware. It's something we are very used to do at 6WIND because our vRouter technology started from our source code product. So porting 6WIND technology on different hardware is really something that we are comfortable with, and this smart NIC topic is also in progress.
Good. Next question. Does your VRouter offer come with a 24 support policy?
Yes, we have an extended support offering with 24 hours a day, 7 days a week support capability. We have support teams spread over the world, so we can answer to our customers any day, anytime.
Excellent. Next question. What is the average improvement in performance with Turbo IPsec?
So that's a hard question because it really depends on the number of protocols you have in your use case. Generally, we say we do. So I guess it's over Linux, this performance improvement. So generally, we do between 10 and 40 times the Linux performance. So it's really dependent on the use case. The best way to answer this question is to do your own benchmarks, and in your use case, use one of our evaluation versions. So it's a very easy process. Just contact us. We provide you with a binary for evaluation that's not limited in terms of performance and features, so you can deploy your own use case and make your performance measurements.
Okay. Next question: how do you license the vRouter?
So for the binary version of the vRouter, I guess that's the question. We license per throughput. So we have different licenses from 10 gig to 100 gig of throughput. And in the case of the IPsec flavor of the vRouter, we also license per number of tunnels. So we start with 10 gig 10 tunnels up to 100 gig 10 gigs 10K tunnels up to 100 gig 100K tunnels.
Next question: what are the main differences you can mention between 6WIND and DPDK?
Sure. So good question. So DPDK is basically a set of drivers that enable high performance input and output. But once you have DPDK, you have to develop a networking stack on top of it. And that's what 6WIND's been doing for the last 15 years. We have developed a high performance networking stack, which by the way, was not a DPDK stack in the beginning. So this technology was developed first on MIPS. And we have enhanced and ported our stack on different architectures. And lately on DPDK, we are one of the co-founders of DPDK, so we know the technology, the DPDK technology quite well. So to summarize this, DPDK is a layer that provides input and output at high performance, and 6WIND uses DPDK for input and output, and we provide a complete networking stack with more than 50 networking protocols on top of it.
Excellent. Thank you, Jan. I think we covered all the questions we received for today. So if you like what you saw in our presentation, and if you would like to evaluate 6WIND vRouters, please submit your request on our online form at 6wind.com. On our website, you will also find our product information, regularly updated blog roll, and registration for our monthly webinar series. This webinar is now ending. Thank you, and we hope to see you again very soon.